In this problem, we're given three different pieces of information. What we're told at the beginning is there are 2 grams of amoxicillin in every 100 milliliters of solution. That is a concentration where we have an amount of medication dissolved into a total amount of solution. The second piece of information said 25 drops per minute. Any volume divided by a time is a rate. And then the last piece is 60 drops per milliliter, which tells us the size of the drop, and this is really how to convert between drops and milliliters. So we're given a rate in drops per minute, and we can convert that to other rates using the drip factor or the concentration. So I just want to start by saying, let's convert this rate to different forms. So 25 drops a minute, if I take 25 drops per minute and divide by the drip factor or multiply by the inverse, I really focus on getting units to cancel out. So I'm going to divide by 1 milliliter per drop. This will give us the rate in milliliters, 25 milliliters every 60 minutes. It's a rate, but now it's milliliters to minutes rather than drops per minute. And if you want to know the rate of the actual medication, the amoxicillin, we're going to use this concentration. I can take the 25 milliliters every 60 minutes and divide or multiply by the concentration. Again, focused on canceling out units, we will find that this is going to be 50 grams every 6,000 minutes. So these are all rates on the exact same setup, just based on different rates, whether you want to know the drops, the milliliters, or the grams. So this problem asked a couple things. The first part is, how long will the infusion take? So if we want to know how long, and we're trying to dispense 100 milliliters, I might use the 25 milliliters to 60 minutes, and I'll just set that up a ratio. I can say if 25 milliliters takes 60 minutes, 100 milliliters will take how many minutes? In this case, 100 times 60 divided by 25, we're going to find out that this is going to be 240 minutes or 4 hours. Because I'm just using this. I could have done the same thing with the 50 grams in 6,000 minutes. And I want to find out how long. Well, if I used 50 grams is 6,000 minutes, 2 grams is how long. And if I do 2 times 6,000 divided by 50, I'll still get 240 minutes. We just don't know how many drops were in 1,000 milliliters at the beginning. I could have figured that out, but I'm just going to do that unit conversion over here. So we know that this is going to take 240 minutes to dispense. So it will take more than the required amount of time. And the second part says, how many milligrams of amoxicillin will the patient receive in 2 hours? Well, that's simple. That if it takes 4 hours to dispense, and 4 hours is going to be 100 milliliters, well, 2 hours, half the amount of time, is only going to be 50 milliliters. It's only going to be 250 milliliters. In which case, 50 milliliters X is going to be 1 gram or 1,000 milligrams. What if I use this rate and said if I get 50 grams is 6,000 minutes? I could just say, I'm going to erase some of this now. I'm going to come back right here. If we get 50 grams in 6,000 minutes, how many grams are going to be in 120 minutes, which is 2 hours? And this would also, 120 times 50 divided by 6,000, give us 1 gram, because 120 times 50 is 6,000 divided by 6,000. So the key is to be able to take a rate that is given and convert it to other rates based on the information of the drip factor or the concentration, and then use the rate that you are most interested in to find out what the rate will be based on the different information that's provided.